I'm back. So today, we did the first lesson from this slide set already. So I talked about the new test, but today I want to talk about an FRQ skill that you will need if you are taking the AP test. So I included this picture because one of the things that this FRQ talks about is pollination. And so if you're a little fuzzy on pollination, this is when insects, animals, wind, and water can transfer the sperm of the plant or the pollen from the male part of the flower to the female part of the flower. And they accidentally do this. They're there to get the nectar and don't even realize that they're pollinating. But that topic is going to come up in this FRQ. But today, my main goal is to define error bars. Not the air around you, but error as in mistakes. And really, this isn't about mistakes, but it's about uncertainty. So in biology, when we do measurements, sometimes there's an error when we collect the data. Or we look at the average. And in the case of the FRQ that we'll work through in my next lesson, which is just going to be in a couple of days, not the course of a week. And so we take the average. So how many times did the bees visit the plant? Or sometimes there's just an uncertainty when we're collecting data, right? Did we look away? Did we get distracted by something? And we missed one of the times a bee could have visited the plant. So this is when data, right, we can't be 100% certain that it's correct, and this happens a lot when we work with living things. And in this FRQ, the data that we're going to look at, just a minute, is the impacts of caffeine on bees' memory. But today I really just want to focus hard on what an error bar is. So these are error bars. So this is a traditional bar graph. And AP Bio is really going back to bar graphs for some reason, so they're super fast to draw. But this is an error bar. So this error bar says that this, right, when they were averaging this, right, this was the average, but it could have been plus this much more or minus this amount. So each of these is plus or minus. So this one has a pretty long error bar. So that's all an error bar is. If we were looking at a data table and they said we had to graph this data in a bar graph, we would know that the average height of the seedling could be plus or minus 0.5 millimeters from these three values. So your first one, right, you would go to 13 millimeters. So let's just pretend. Right, this is 13 millimeters, but this is plus or minus 0.5 millimeters. So you would have to graph that to show that difference. So in the case of the data about the bees, and I'm just defining what an error bar is, they told us that at 10 minutes, the control, right, the average probability of it revisiting the same flower again and again because it liked it so much was 0.72 plus or minus 0.09. For the caffeinated one, right, at 10 minutes it was 0.83 plus or minus 0.07. So it could be a little bit above or a little bit below. Same for at 24 hours. So when I made my graph, it looks like this. So I plotted all my plots out, got it all right, and then I said, all right, 0.09. So I had to had to fluctuate with it when I worked on this, and I plotted it out, and I have my error bars. But the important thing to remember is error bars are showing uncertainty. So they took an average and they graphed that average. So this was a little bit above 8, let's say 8.3, but it was plus or minus this amount. So That's all an error bar is showing that uncertainty, that maybe they weren't exactly on. And in the case of this lab, right, how many bees were they testing, right, in this experiment that we're going to look at? Did they look away, like I said earlier, and miss a bee? Were they distracted? Make sure I'm not missing anything. So, I am going to put a live document with this video. Wanted to make sure that you understand what an error bar is before we move on and tear up this FRQ. So I think that's it for today. See ya.